This is 4.5a, mutually exclusive events. So mutually exclusive events are two events, or I guess could be more than two events, but are events that if one event happens, the others cannot. Okay? Meaning they never occur together. They cannot occur at the same time. It's like asking someone to draw a 3 and a 9 from a deck of cards in one card pool, right? You can't do it. If you draw one card, it could be a 3 or it could be a 9, but it can never be both a 3 and a 9 at the same time. Okay, so those are mutually exclusive events. They never occur at the same time. So in example 1, we have 3 events. Event A, Event B, and Event C. Event A is the sum of 2 dice is 6. So notice we're rolling 2 dice. So event A is getting the sum of 6. Event B, the sum of the 2 dice, is 11. And event C, the 2 dice are the same number. All right, so are events A and B mutually exclusive? So mutually exclusive, remember, that means if one happens, the other cannot. So are they able to not happen at the same time? Mutually exclusive means cannot happen at the same time. Okay, so can they not happen at the same time? A and B, yes. If I rolled 2 dice, I could have a sum of a 6 or a sum of 11. I can't roll the 2 dice and have both a sum that is 6 and 11 at the same time. That doesn't make sense. So yes, they are mutually exclusive because they cannot happen at the same time. Okay, now we look at events A and C. Sum of 6, they are the same number. Are those 2 events mutually exclusive? So that means they cannot happen at the same time. So can I roll dice and get a 6 that is also the same number? I can. So that means they can happen at the same time. So the answer is no. They are not mutually exclusive. They can happen at the same time, making them not mutually exclusive. Right? If I get a 3 and a 3, that is also the sum of 6. Same number twice, sum of 6. Are events B and C mutually exclusive? So sum of 11 and 2 dice that are the same number. Well, on a dice, I'd have to get a 6 and a 5 to make an 11. That means they cannot be the same number. So yes, they are mutually exclusive. They cannot happen at the same time. And so that is kind of the introduction of the new term, understanding mutually exclusive. That's really all we're looking at today. So with mutually exclusive comes the addition rule. Okay, the addition rule is for or. So if you see probability of one thing or another thing, you have to relate that straight to the addition rule. Okay, that's going to be an important thing. If it says or, you're thinking addition rule. The addition rule says the probability of A or B equals the probability of event A happening plus the probability of event B happening minus the probability of both event A and B happening at the same time. And we have a second clause that is part of that equation. If they are mutually exclusive, the probability they both occur at the same time is 0. That is the definition of mutually exclusive. They cannot happen at the same time, so we would have a 0 probability. Okay, so drawing one card from a deck, find the probabilities. All right, the first one, probability of red or queen. As soon as I see that or, I think addition rule. Okay, and we also need to ask ourselves, is it mutually exclusive? Okay, so red and queen. Can those occur at the same time? Basically, is there a card that is first red and also a queen? Yes, we have the queen of diamonds and the queen of hearts. Those are red queens. So are they mutually exclusive? No. They can occur at the same time, meaning they are not mutually exclusive. Okay, So I'm going to write out my equation with my events filled in. A is red, B is queen, so probability of the red plus the probability of the queen minus the probability of the red queen. That is both occurring at the same time is when I have a red queen. All right, so probability of red, that would be how many red cards in my deck. So it's out of 52. Remember, we're only drawing one card, right? We're drawing one card, and we're trying to find what is the probability that that one card I drew is either a red card or a queen card. So it's 26 out of 52 for red, plus probability of queen. Okay, so I got to think, well, with the probability of a queen, I have 4 queens in the deck, so 4 out of 52, minus the probability of getting both. Because if you think about it, when I counted the queens, the red queens in the red, I counted them again when I did the queens. We double counted basically, so that's why we have to subtract them off. Since they can't occur at the same time, we have double counted. So a red queen, how many red queens? So I already said it's queen of hearts and queen of diamonds, 2 out of 52. Okay, we don't want to simplify right away because we need a common denominator to add and subtract fractions. So I just have to add and subtract the top. So 26 plus 4 minus 2 is 28. And then I would simplify or divide. I would just divide at this point, 28 divided by 52, and move the decimal twice to the right, right? You get a decimal, move it twice to the right for the percent, and I get 53.8%. You should use your calculator to see where that's coming from. Okay, so there we go. All right, we got an OR again. So I'm thinking addition rule right away. You're going to see a common theme here because they're all going to be really addition rules. So we have to ask ourselves, mutually exclusive. Is this mutually exclusive? Ace or face card? Can I have an ace and a face card at the same time? Well, yes. Wait, no, I can't, right? Ace is not a face card. Don't forget that. So they can't occur at the same time. So that means yes, they are mutually exclusive. They cannot occur at the same time. They are mutually exclusive. Okay, so thinking of my addition rule, it's the probability of ace plus the probability of face card minus the probability of both But we just said they're mutually exclusive, so that means this last probability that we're going to subtract is actually 0, if you know what you're talking about. If they are mutually exclusive, they cannot occur at the same time, making that last thing 0. So aces, I have 4 out of the 52 cards. Face cards, we have 12 out of 52 cards. Minus 0 cannot occur at the same time, so that ends up being 0. So I add those up and I get 16 out of 52, and I just take out my calculator, type it in, 16 divided by 52. Remember, it's a decimal. We move the decimal twice to the right. I like to write it in percents because I think percents are easier to understand than anything else. And there we go, 30.8%. All right, so once again, addition rule. We ask ourselves, is it mutually exclusive? So a non-face card and red card. Can I have red non-face cards? Yeah, I have a 2 of hearts, 4 of hearts, 3 of diamonds, 10 of diamonds. There's a lot of them. So no, they are not mutually exclusive. They can occur at the same time, meaning they are not mutually exclusive. So I have the probability of a non-face card plus the probability of a red card minus the probability of a red non-face card, right? Combination of them, both at the same time. Okay, so non-face card, that's 40 out of 52, plus a red card is 26 out of 52, minus a red non-face card, okay? So half of a deck is red, so that means half of my non-face cards are red, meaning 20. So 40 plus 26 minus 20 gives me 46. Pretty high. So if I divide, move the decimal twice to the right, 88.5%. All right, and then we get to the last one, or, so there we go. So 3 or green. That's confusing for a lot of people, especially if you pay attention. Not even gonna, I guess I am gonna ask if they're mutually exclusive. So can I have a 3 that is also green? Well, I can't have any green cards in the deck at all. So yes, they are mutually exclusive because they cannot occur at the same time, because a green card can't occur at all. So when I write out my probabilities, it's not very confusing if you separate it. So probability of a 3 plus the probability of a green card minus the probability of a green 3 card. So I have 4 out of 52 plus 0, because there are no green cards, minus 0, because there are no green 3s. And so I just get 4 out of 52, which we divide, move the decimal twice to the right, 7.7%. Okay. And that's it for these notes. So you can write your 3-sentence summary talking about mutually exclusive events, the addition rule, and you're happening at the same time.